Hi there. The following tutorial is to help you draw reaction mechanisms on Pearson homework. Alright, so let me go to the homework that we currently have. And we can start from there. So I'm going to go to assignment 7. And this tutorial in particular will cover problems 15, 32, and 35, which are 3 mechanisms that I requested you to do. Alright, so let's go to 15. So I'm going to do standard view. So yeah, so this is what you have. So you will get this problem, and it's going to tell you draw a mechanism for the following reactions in which 2 equivalents of bromine are used. All right, so one thing that helps me do these mechanisms is to actually draw them on paper first. So I'm gonna go ahead and draw that. So let's see again. So it's 1, 2, 3, 4, 5, 6 carbons. It's symmetrical with a triple bond in the middle, and then bromine. Okay, I got it. So it'll be triple bond, and then 1, 2, 3, 4. Let me see. No, I think it's 1. Yeah, 2. 1, 2, 3, 4, 5, 6 carbons. All right, so we're gonna do that, and we're gonna add bromine to this. So if I have bromine, I will have the following. So I have electrons, 6 electrons around each bromine. The double bond attacks. Actually, let me move this down here. So we're gonna do it right away. We're gonna put the triple bond here. And so this triple bond is gonna attack the bromine, and these 2 electrons that are here are going to go with this bromine as a leaving group. And when that happens, simultaneously, you can grab any of these lone pairs. I'm gonna grab this one right here, and I'm gonna put it right there. All right, so this is how Pearson works. You have to start the arrow from the lone pair. If not, it's not gonna work. And you have to highlight the atom that you are attacking. In this case, this carbon right here. You have to highlight it. And then Pearson has something that is interesting. It will put like a little dotted line. All right, and so you do that, and now you will have a bromonium ion. It'll look like this. You have the 2 carbons, ethyl groups. Your bromine will be plus, and you'll have 2 lone pairs on each side of the bromine here, and then you also have a bromine that was kicked out. 1, 2, 3, 4, 5, 6, 7, 8 for this one. Say 8 electrons. And so most likely when you trace the attack, you want to attack right there, right? Then Pearson is going to give you like a little dotted line, and then it's going to reorganize your arrow, and it's going to put it right here without you asking for it. So go ahead by all means and attack that carbon and let Pearson's software reorganize. And then also make sure you point towards that bromine to break the bromonium ion intermediate. So that'll make that. and then you're going to be making this. So notice that this bromine is the one that was on the top and the bottom attack. This is the bromine right here from the bottom attack. It's anti, and you get that. All right. So then another, because you have two molecules of bromine, another bromonium ion has to form. So you have that. You have all these electrons. And so this double bond is going to attack this bromine, and the two electrons here are going to be transferred to that bromine. And then you do the double slap. So most likely grab this and attack there, and then you will have the 3-member ring bromine plus with two lone pairs. There will be a bromine here with 6 electrons, one here, and that. Then you will have this bromine that was kicked off here. You'll have it from the top now because it's an anti-attack, and so that's gonna come and attack right there. When it attacks right there, it opens up this, and then you have final product, and that should look like this: bromine, 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 4 bromines, that, and that. And don't forget to add the electrons around the bromines, 6 on each. All right, that will be the end of this problem. All right, let's see. Let's do it together. So I'm gonna go and grab problem number 15. It's right here. How do I want to do this? Let me redo it. I think there was something weird. All right, here we go. So I want the standard view. Oh, it's getting stuck. Okay, here we go. Because I'm an instructor, it gives me the answers and all that stuff, but I don't need that. Matter of fact, I try to do this so that if I can do it, you should be able to do it. All right, so now we're going to be drawing this molecule. So notice that here we have the scheme, the reaction scheme. So we'll go 1, 2, 3, 4, 5, 6 carbons. I'm going to emulate what I have here on the top, like this. And so it actually starts rearranging. So if you want the double bond, the triple bond, you have to click this little black triangle that comes here. Make sure you have the right geometry, so triple bonds are linear. And so I'll do that. So what this is doing is actually putting all this CH2s as condensed structures. It's a mixture of condensed with linear structures. All right, I can handle that. Let me move this down a little bit. So I have room for the bromines. So the bromines, I'm gonna get them from here. Get 1 and 2. And if I trace a bond between the two, It fixes them up. It puts the electrons, so I don't have to worry about that. It's fast. That's a unique feature of Pearson, actually, that you have this generation of electrons by itself, by the software. All right, so here's the trick. Now I'm going to be using, notice that I have full arrows and single arrows for radical reactions, so we're going to be the full arrow. And so for this particular reaction, I want to start the arrow in from the triple bond. So that's the one that is going to do the attack. So notice that I approach the atom of bromine and I highlight it, but immediately the Pearson homework puts that dotted line and it organizes the arrow so that it's actually aiming towards the dotted line instead of the actual atom. So notice what I do. I go from the triple bond and I highlight the bromine, and then boom, it changes it. It changes the arrow down. All right, now it keeps it like that. It's not what I told it to do, but that's what it does. Then I also gonna break immediately when I do that. I'm gonna break that, and I'm gonna transfer these electrons right here. So I need to highlight that bromine, and now it self-organizes the arrow. And so I believe that this mechanism goes via what I call the double slap. So I'm gonna grab this bromine and I'm going to highlight it here to this carbon. I'm highlighting the carbon. Notice the circle in blue, but the software is putting that dotted line and the arrow attached to it. So I just let it go, and that is correct according to this software. Then I need to keep on going. So I'm gonna put another arrow here to represent that I'm moving towards the right. And so now let's see if I can just copy all this. I'm gonna copy that. Let me see. I think I have to use my keyboard, so I need to open my computer. Let's see if that works. Control C and Control V. Click outside and then Control V. Yeah, it works. That's awesome. So I don't need to redraw the whole thing. I'll just delete some of the things. Oh, undo that. All right, that's what I'm gonna delete these things now because they're on the way, and I'm actually gonna turn that triple bond into a double bond, and so it'll look like that. But then I have to maybe make a tri-member ring with a bromine here. That is in red because it needs a plus charge. So I'm gonna go there and put the plus charge, and it puts it right there. So this is my first reaction intermediate, and then I also need a bromine. This bromine will be right here. I'm gonna put it in there, but it says HBr, so automatically the software puts an H. So I need to put a negative sign on the bromine to take care of that. See, the H disappeared. Every time you put a negative charge, the H disappears. And now I'll go to the arrow again. Notice I'm highlighting the bromine and I'm going to attack. Hold on, let me see. Oh yeah. Okay, notice that I couldn't get the arrow going. And this is the thing. So if you highlight, but if you highlight in the center of the atom, it's not gonna work. So you need to highlight the atom, but then go to the side and point towards one of those two lone pairs, and then the arrow will come out. You see that? Now I am highlighting this carbon right here, and I'm going to let it go, and it's gonna self-make again this little dotted line and put the arrow right there. You don't control that, the software does. All right, so we'll do that, and then also we're going to break that triple that so from here, so the arrow should come from the bond to the bromine, and boom, I got it. So that's that. And now I can highlight this part, and I'm gonna copy and paste it. So what I do is I highlight, copy, click to release the highlighted thing, and then Control V gives me it repeats that unit. Oh, that's not the one. So let me do this. So all right, hold on a second. I have a problem here with, I cannot see the end. Okay, here we go. Let me reduce this a little bit. All right, so now I'm going to delete some of these things. Oh no, undo that. Click and then delete these things. That to reorganize my molecule, I will have a bromine up and one bromine down. Sort of like this. And I still have a double bond. All right, and so the next thing is I'm gonna get another molecule of bromine, doing the same thing. Put bromine on the left and to the right, and a second one of this bromine molecule is going to be attacked by the alkene. Look for the arrow, highlight the center of the double bond because that's what's going to do the attack. And so then you come and attack one of the bromines. Let's say you want this one, you highlight it, but notice that the arrow is the software making that dotted line with the arrow pointing towards it, and you just release it. Then here you want to transfer this electron towards this bromine, so you do that, click it, and then you do the double slap now, point towards one of those electrons, and now highlight the carbon that you're attacking, and that's it. Notice that it put the elongated trimember ring bromonium ion. Even though the electrons here are kind of weird, this is how you do this. Then put another arrow here. We're going forward. I'm going to again highlight this. Control C, click, Control V, drag it down, click, and then clean up the structure. So what we have here, it's we want to have a single bond now here, and we're gonna have, let me move this bromine to, no, I cannot move it. Alright, so I'm gonna put a trimember ring here, trimember ring with a bromine, and that bromine is in red, so we need to put a plus charge to make it happy. Boom. Alright, notice that bromine has 2 lone pairs. The bromine on the right has 3 lone pairs, and so all we need to do now is one more bromine attacking, and I'm going to put a negative charge to it so that it looks like a nucleophile. Look for the arrows, highlight the bromine, and then slide to one of the lone pairs, and that's going to generate that attack. Notice the attack look for the carbon, and then it retrieves and puts a dotted line, and then it reorganizes the arrow And then for this final one, we're breaking this. So we're gonna do it like that. Hold on, like that. All right, and so we're going to put this out. I think I'm running out of space here. All right, yes. All right, I got it. I want to highlight all of this and move it. I need space. All right, so I'm gonna put my final product here. I'm just gonna highlight this. Control C, click Control V. That saves a lot of time for you to redraw in these things, and undo that. Now delete what is not needed. So I'm gonna delete that, and I'm just gonna put one bromine up and a bromine down, and the software takes care of putting the electrons. So this should be it. This should be it. This should be good. And I'm gonna submit. It says a mechanism must contain at least 2 rectangles, one containing star materials and the other products. No credit loss, try again. Oh, great. I need to put this in rectangles. No wonder. That's new for me. Oh, here's the rectangles. So it's maybe something like this, and you need to touch the arrow. I'm gonna make it touching the arrow. This one too. Yeah, and I think it needs to touch the, yeah, the arrow needs to touch the square. It's gonna go like this. And then I'm gonna take care of those arrows. Alright, so this arrow from here to here, see, you need to touch it so it activates it. From here to here. From here to here. And let me delete this. From here to here. Alright. So all those squares need to be touching. I'm going to submit. It better be right, because I don't see anything else. Okay, that's good. Yeah, so that's how you would do that. Alright. So let me check on the recording. I hope it's recording. I think so. Sometimes it doesn't. Okay, so we finished the first mechanism. Let's do number 32 real quick. So I'm gonna close here, and I'm gonna do number 32. So another mechanism. I don't need to see the answer. Standard view. So this one is really easy actually. It says predict the acetylide form in the following reaction and draw the mechanism of its formation. Where is, oh, right here. Oh, that's one standard view. Okay, He said draw the missing reactants and or product in the appropriate boxes, but I see the boxes already filled out. Oh, I did this mechanism before. I was practicing. Let's see. How can I do it again? I'm gonna delete this. Okay, undo. I just want to delete this. Okay, so basically the mechanism just calls for show the electronic flow. So grab the arrow, double-headed, the full-headed arrow, and then you're gonna grab the H, and that's going to put the arrow on the dotted line, and then I'm going to grab the bond that has the 2 electrons. I'm going to transfer those 2 electrons to this carbon. All right, check this out. Let me delete this thing here. So basically we have this, and one more thing, that nitrogen, that ammonia simply is nitrogen. So if you put nitrogen right here, boom, it generates the 3 electrons. I mean the 3 hydrogens and the 1 lone pair of electrons. All right, so one more trick. You want an acetylide here, simply grab the minus charge, click it on the carbon, boom, it puts the negative charge and 1 lone pair, and this is it. So this is how this mechanism will be. Let's do number 35 now. I haven't done that one, so that's good. So we're gonna go here, click on 35, and let's see what it says. I want the standard view. Give me the standard view. I want to solve this problem. Okay, so check this out. It's already drawn for me. All I need to do is show it said draw all missing reactants and or products in appropriate boxes by placing atoms on the canvas and connecting them with bonds. Add charges where needed. Electron flow arrows should start on the electrons of an atom or a bond and should end on a bond it should end on an atom, bond, or location where a new bond should be created. All right, so we're going to, here's my nucleophile, is also my base. I'm gonna grab the this arrow, and I'm highlighting the nitrogen, but I'm gonna lean towards the electron so that the arrow can come out. I'm gonna grab this H, and immediately notice that the software reorganizes. Before I touch it, it looks like I'm reaching to the hydrogen, and then boom, it changes to the dotted line. Once it changes to the dotted line, that means you are aligned. You can just let it go. And this arrow now pointed towards the dotted line means you're grabbing the H. All right, so from here, I grab the 2 electrons from the bond, and I'm gonna put it on the carbon. And that is going to make, my, actually I erased it by mistake, but I'm gonna draw it. How do I draw it? Easily. I just highlight this, Control copy, Control C, Control V. I don't need to be redrawing all this. Once you do this several times, you're going to speed up the process. All right, how do I make a satellite here? So simply grab a negative charge and put it in there in the carbon, and delete this H, so that puts the satellite ion there with a negative charge and 1 lone pair. And then that's also now my nucleophile. I'm gonna grab arrows that are full arrows, and I'm gonna highlight a C, but then I'm gonna lean towards the right where the electrons are so that the arrow can come out. and I'm going to attack this carbon right here, because that's the carbon that's holding the living group. And notice that now the software, if I go around like that, it's going to always put that dotted line. So I'm going to put it right there. That is correct. And then one more thing I need to do, I need to kick off this bromine. So I'm going to transfer those two electrons here, and it's going to fix it like that. And believe it or not, we're finished. Notice that this also this arrow is already fixed for you. They need to touch both boxes. That is one way of the software to say, hey, this connects to that. All right, so submit, should be good. Boom, finish. And that's the end of my recording. I hope you enjoyed this.